Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2014 for 2 marks in state 3. Basically this question was asked on counter flow heat exchanger to find the log mean temperature difference in case of counter flow heat exchanger. So let us understand the question. The question is, a double pipe counter flow heat exchanger transfers heat between two water streams. Now my dear students, in the question they have given counter flow heat exchanger. So let us draw the temperature distribution for the counter flow heat exchanger. Now for counter flow heat exchanger, the inlet and exit condition of hot and cold fluid is different. That is, let us say if hot fluid is entering from the left side, that is Thi. Now while flowing, the temperature of hot fluid will decrease and the exit temperature of hot fluid will be Tho. Right, this will be the hot fluid. So as hot fluid is flowing from left to right, the cold fluid will flow from right to left. Therefore, here the entry temperature of cold fluid Tci will be towards right and exit temperature of cold fluid will be towards left. Therefore, here cold fluid is moving from right to left and the exit temperature of cold fluid is Tco. Right. And my dear students, this left side temperature difference Thi minus Tco is called delta T1, and right side temperature difference, that is Tho minus Tci, is called delta T2. Now let us go back to the question. Tube side water at 19 liter per second is heated from, now water is heated from means it is a cold fluid, the temperature is increasing, the temperature of cold fluid is increasing, therefore the cold fluid volume flow rate is given 19 liter per second, right? So my dear students, here and the inlet and exit temperatures of cold fluid are, therefore Tci is given, Tci is 10 degrees Celsius, right? And then Tco, exit temperature of cold fluid, will be equal to 38 degrees Celsius, right? And here volume flow rate is given and it is nothing but mass flow rate, because my dear students, 1 liter water I am saying, not for other fluids, 1 liter water is always equal to 1 kg water, is always equal to 1 kg water. This is valid only for water if density is 1000, right? For rest fluids it is not valid. Now let us see, here density of water is given 1000, density of water is given 1000. Now my dear students, 1 liter means volume, liter is a volume, right? Therefore here volume is 1 liter. Now 1 liter means it is 10 to the power minus 3 meter cube, therefore volume is 10 to the power minus 3 meter cube. Density is given 1000 kg per meter cube. Therefore my dear student, density is nothing but mass divided by volume, therefore mass is equal to density into volume, which is nothing but 1000 into 10 to the power minus 3, which is equal to 1 kg, right? Therefore my dear students, whenever density is 1000 kg per meter cube, then 1 liter volume is always equal to 1 kg mass, right? Therefore here 19 liter per second is nothing but 19 kg per second also, right? This is how we can understand. So my dear students, here the mass of flow rate of cold fluid is given, so let us write down here. Therefore we will say the mass of flow rate of cold fluid is 19 liter per second, which is nothing but 19 kg per second if density is 1000, right? Again, is heated from 10 degrees Celsius to 38 degrees Celsius. Therefore inlet temperature of cold and exit temperature of cold is given. Cell side water at 25 liter per second, again water, again my dear students, water, density of water is 1000, therefore 25 liter per second is nothing but 25 kg per second. Therefore here mass flow rate of hot fluid is given 25 kg per second. Now again the cell side water 25 liter per second is entering at 46 degrees Celsius. Now it must be a hot fluid, as already we have written for cold fluid it must be a hot fluid, therefore mass flow rate of hot fluid and entering temperature of hot fluid, that is Thi is given, which is 46 degrees Celsius, right? Then assume constant properties of water, density is 1000 and specific heat is 4186 joule per kg. Here specific heat of water is given. Specific heat of water is nothing but specific heat of hot fluid as well as specific heat of cold fluid, because here hot as well as cold fluid is water, right? Both fluids are water, right? Therefore here the specific heat will be same. Therefore my dear students, this specific heat is given 4186 joule per kg Kelvin, right? Then the LMTD in degree Celsius is, now here we have to find log mean temperature difference. Now my dear students, to find this log mean temperature difference, we have derived formula in theory lecture, that is it is equal to delta T1 minus delta T2 divided by ln of delta T1 divided by delta T2, where delta T1 is left side temperature difference, that is Thi minus Tco. Delta T2 is right side temperature difference, that is Tho minus Tci. Now here Tci, Tco is known and Thi is known. Therefore, we have to calculate for Tho. If I calculate this Tho, then I will get this LMTD. Now, my dear students, here can I say the heat transfer is equal to, if I consider cold fluid, it is mCp of cold fluid into temperature difference of cold, that is Tco minus Tci. And if I consider hot fluid, it will be equal to mCp of hot fluid into temperature difference of hot fluid, that is Thi minus Tho. Right. Now, my dear students, here both cold and hot fluid are water, therefore specific heat is same. So let us cancel this specific heat. Now, but mass flow rate is different here given. Therefore, let us put here. Therefore, we can say m of cold fluid Tco minus Tci of cold fluid is equal to mass of hot fluid Thi minus Tho of hot fluid. Right. So let us put the values. Therefore, mass flow rate of cold fluid is 19, Tco is 38, Tci is 10, is equal to mass flow rate of hot fluid is 25, Thi is 46 minus Tho we have to calculate, right? If I equate this, I will get Tho. So let us find this hot fluid exit temperature, right? If I solve for this hot fluid exit temperature, I will get 24.72 degrees Celsius, right? Now, once this hot fluid exit temperature is calculated, now let us put this hot fluid exit temperature in this temperature profile and use this LMTD formula, right? So let us move back to the LMTD. Now let us find this LMTD. Therefore, here this LMTD formula, log mean temperature difference, is equal to, here we have written formula delta T1. Delta T1 is nothing but Thi minus Tco. Therefore, it is Thi minus Tco minus delta T2. Delta T2 is Tho minus Tci minus Tho minus Tci whole divided by ln of delta T1, that is Thi minus Tco divided by delta T2, that is Tho minus Tci, right? So my dear students, this LMTD log mean temperature difference will be equal to, now let us put the temperatures. Thi is 46, Tco is 38, therefore here 46 minus 38 whole minus Tho is 24.72, and Tci is 10 divided by ln of 46 minus 38 divided by 24.72 minus 10, right? So let us solve this equation for LMTD. And my dear students, if you solve this equation for LMTD, you will get LMTD is equal to 11.02. This LMTD you will find is equal to 11.02 degrees Celsius, right? So here in this fill in the blanks, you have to type 11.02 for getting full marks. Therefore, if you type here 11.02, you will get 2 marks. Thank you, dear students. In next lecture, we will see one more numerical on this topic which was asked in previous year GATE examination.